Hello everyone, welcome back to your YouTube class. So in the previous live class I told you that the marks distribution and the syllabus we had covered for your chapter database representation. So the database representation we have for 8 marks and we had covered all 3 marks questions, that is basic conversion from one number system to another number system. We had seen how to convert a decimal number system to other number system like binary, octal and hexadecimal, and in reverse from binary, hexadecimal and from octal to decimal we had seen. Similarly, we had also seen how to convert a given number, that is octal to binary, binary to octal, hexadecimal to binary, binary to hexadecimal, and after completion of that we had also seen the last conversion, that is how to convert a given octal number to hexadecimal and in reverse from hexadecimal to octal. So these are all the examples we had seen for fraction numbers also and for your whole numbers also. And many of you are asking me that how to convert your fraction of decimal to octal and fraction of decimal to hexadecimal. That point I had cleared you in your live class. Then, so we'll move to the next part of your syllabus, that is we have is representation of your signed integer. Next part comes in your syllabus is representation of signed integer. So what happens here, your computers are all digital computers. The computers all works on the digital media, where we say that the digital computers can handle the numbers. For that reason, we had studied these all the number system convergence. We had studied these all the number system convergence. Now what we done is, we had seen all only positive numbers. We had seen all only in the format of your positive numbers. But your digital computers can handle both positive and negative integers. The digital computers can handle both positive and digital. So what we have to do is, we have to represent the numbers in a signed format. Till now, what all the conversions we did is all without sign, means all were the positive numbers, so we did not consider the sign at all. But now, when you are considering the numbers of negative and positive, it is necessary to denote your numbers with the signed integer. The numbers with the signed integer. So what we have to do is, so some means is required for representing a sign of the number. That is, we should know the number is positive or the number is negative. So when you want to know the number is positive or the number is negative, we have to do something for that. So here, this can be done by adding the leftmost number. When you are writing the number, the leftmost number would be right here, the leftmost number, that is your MSB number. That bit you have to make it as a sign bit. That bit you have to make it as a sign bit, and after that one bit, the next what all the bits we write, that is relating to your number value. That should be the number value. So and that part where it gives you the number value is called as your magnitude. Is called as magnitude. Done? So just understand till now what all the number system we had converted from one number system to another number system without sign we had taken, means unsigned values we had taken. The numbers we did not have the positive and the negative sign. For example, when you want to convert 28 to the binary, directly we divided by 2 and we had calculated the answer. But here 28 is a negative or a positive number that we had not considered. Then now we'll study how we can represent the signed integer. That means how we can represent minus 28 and plus 28. That we have to study now. For that we have to do something. So the scientist and the numerals says that we have to use the leftmost bit as sign bit, and after the leftmost bit what all the value of the integer we write, that is called as magnitude. That is called as your magnitude. Clear? So what we do is, we add a leftmost bit and it will be considered as your sign bit. Then and others will be considered as your magnitude. Then now what we write in that leftmost bit? What we write in that leftmost bit? If your leftmost bit is 0, then we are talking about only binary numbers, because now we are starting with the digital computers. We are speaking with the digital numbers, means everything you have to convert in the format of binary numbers, that is 0 and 1. Then now when you want to add the sign bit, the leftmost bit is your sign bit, and if that leftmost bit is 0, then your number is positive. Your number is positive. Then if that leftmost value or a leftmost bit is 1, then you have to consider that your number is negative. Your number is negative. Then so suppose when I have to represent 20 minus 28, then my first bit will be 1. And if I want to represent plus 28, then my sign bit, that is first leftmost bit, will be 0. And the other part what I write will be the value of 28. Will be the value of 28. Clear? When we want to represent the sign of your integer, then we use the leftmost bit of that number. And that leftmost bit can be 0 or 1. 0 means your number is positive. 1 means your number is negative. For example, I want to denote 12. So the 12 value, I know that 1100. I'll refer the 841 method. I refer the 841 method. So 12 value is 1100. Now this is unsigned integer, because sign bit I am not using. I am not using sign bit, means this is the unsigned representation, I can say. I'll write here unsigned integer. We just say unsigned integer. Now you want to represent this 12 as minus 12 and plus 12. You want to represent 12, that is 1100, with the sign bit. Then you have to use the one extra bit here. The one extra bit, that will be either 0 or 1. That will be either 0 or 1. Now I'll write here. See, 12 value is 1100. Then now if you want to represent minus 12, how we will represent? The first leftmost bit will be your sign bit. So what is the sign of negative numbers? For negative numbers we use 1. So my leftmost bit is 1 and the value of 12 is 1100. So this is sign bit. This is sign bit. Clear? Now if I want to represent plus 12, if I want to represent plus 12, then my sign bit will be positive number 0. So I'll add 0 and the value of 12 is 1100. So this will be plus 12 and this will be your minus 12 value. Then like this we represent your signed integers. Yeah? So this method is called as fixed point representation. This is called fixed point representation. So what do you mean by fixed point representation? For your binary number, if your leftmost bit is your sign bit, it is fixed to represent the sign of a given number, then that representation is called as fixed point representation. That point is called as that format is called as fixed point representation. Clear? So here a negative signed integer can be represented in 3 ways. A negative or a signed integer can be represented in 3 ways. So we can represent in 3 ways. We'll see which all those. The very first method we have is sign and magnitude represent. Sign and magnitude representation. What is this? First method of representing your sign integer is sign and magnitude representation. And the second one we have is ones complement representation. Ones complement representation. The first one is sign and magnitude representation. The second one is 1's complement representation. And the third last method in your syllabus we have is 2's complement representation. 2's complement representation. Done? So we have totally 3 ways to represent your signed integer, especially your negative signed integer. That is, the first one we have is sign and magnitude representation. The second one we have is 1's complement representation. And the third one we have is 2's complement representation. Done? So we'll study one and other in detail with the example. Done? So we'll see first one. First one we have is sign and magnitude representation. Sign and magnitude representation. So here an integer containing a sign bit is followed by magnitude bits are called as your sign bit integer. So what we do here in this method, we use to represent signed number. So what we do here is we divide into 2 parts, as I told here in the previous sessions. In previous example I told you it has been divided into 2 parts. That is the main example of your sign and magnitude representation. What we do here, we divide your given number into 2 parts. The first part is your sign bit, which will tell what is the sign of that number, and the second part we write the magnitude. We write the magnitude. Here magnitude is nothing but actual number. Magnitude is nothing but the actual number. Understand? If I want to represent plus 10 and minus 10, plus 10 and minus 10. So the value of 10, we know that 1010. Then, so this 1010 is magnitude. Your 1010 is magnitude. For plus we are writing 0 and for minus we are writing 1. That will be your sign bit. Then, so your sign and magnitude representation says that a given number must and should have 2 parts. The first one is sign bit and the second one is magnitude. Magnitude means actual value of your number, and sign bit contains only 1 bit which will tell your number is positive or negative. Which will tell your number is positive or negative. If your number is positive, write 0. If your number is negative, write 1. And in magnitude, the value of the number will be written. Cleared everyone? So what is your sign and magnitude representation says? An integer containing sign bit followed with the magnitude bits are called as your sign and magnitude integer. Done? So here in your given number, always the MSB will be your sign bit. The MSB will be your sign bit and the remaining bits are always stand for your magnitude. For example, if I written 0, 1, 0, 1, 0. So this is your sign bit and the remaining bits will be called as your magnitude. Your remaining bits are called as your magnitude. Clear? Sign bit, the MSB bit, the first bit, only 1 bit, that is your sign bit, and the remaining after your sign bit, which all the values we have, which all the bits combination we have, those all are called as your magnitude. Clear? So before seeing the example, let me give you the meaning. You can write your meaning. An integer containing a sign bit. Write down an integer containing a sign bit followed by magnitude bit are called as sign and magnitude we can write, or sign magnitude, integer or the representation. I am talking about integer, so I'll write a word integer. Done. So this method is used to represent negative numbers. Here we have two parts. The first one is sign bit and the second part is magnitude. Done. MSB will be always the sign bit. Then in the sign bit we'll be having 1 and 0. 1 means negative number and 0 means positive number. Clear? These points theory you have to remember. An integer containing a sign bit and followed with a magnitude bit is called as your sign and magnitude representation. The sign and magnitude representation is usually used to represent a negative number. Here we have two parts, one is sign bit, another one is magnitude. Your MSB, the first leftmost bit will be always called as your sign bit and the others followed bits are called as your magnitude. In your sign bit we write two values, either 1 or the 0. 1 means negative number and 0 means positive number. 1 means negative number and 0 means positive number. Clear? So like this, the theory we have for your sign and magnitude representation. We have theory for your sign and magnitude representation. Write down this much. Done? So now we'll see the examples. I'll write the example. The first one, represent plus and minus 35 using sign and magnitude. Question is, show or represent your plus and minus 35, both the numbers, using your sign and magnitude method. Now we'll see. We cannot directly display this 35 in your sign and magnitude format. First what we have to do is, we have to convert your 35 to your binary number. You have to convert your 35 to binary number. Now don't ask me the 35 is in octal or hexadecimal or decimal. Now onwards, what all the digital numbers will get, these all are the decimals and you have to convert them into your binary numbers. Clear? Now what all the digits you will get, all you have to consider as your decimal numbers. If they are preferring like it is octal and hexadecimal, then they will give you the base. If there is no base, means you have to consider that it is a decimal number and you have to always convert it into your binary number. Done? So let me convert first your 35 to your binary number. So you know a decimal number you are converting into binary number means you have to divide by 2. Done? So 2 1s are 1 is remaining 15, 2 7s are 14, 1 is a remainder, 2 8s are 16, 1 is a remainder, 2 4s are 8, 0 is a remainder, 2 2s are 4, 0 is a remainder, 2 1s are 2, 0 is a remainder, 2 zeros are 1 is a remainder. So this will be your LSB, this will be your MSB. From MSB to LSB you have to write the answer. Done. Now 35 is equals to 1 3 times 0 1 1. What is the value of 35? The value of 35 is 1 0 0 1 1. Done. Now plus 35. If you want to represent plus 35, how we represent plus 35? We write 0 1 0 0 1. 0 I had added. 0 because the sign is positive. 0 because sign is positive. We know that if a given number is positive, you have to add sign bit as 0. And if your given number is negative, you have to add your sign bit as 1. That point you have to keep in your mind. Done? So here, this 0 is nothing but your sign bit. This is your sign bit, and this all together, this section is nothing but your magnitude, which will give you the actual value of your 35. Actual value of 35. So here 0 represent it is a positive number. 0 represent it is a positive number. Similarly, if you want to represent minus 35, then what is the value of 35? Is 1001111. 10011. But the 35 is negative. I have to add the sign bit, that is 1. Done. So I had added sign bit as 1 because it is a negative number. This is your sign bit, and this remaining value will be your magnitude. Then clear? What you have to do is, you have to take first the given number. Divide it by 2 because you have to convert that into your binary. Write it the equivalent binary number. Then take the sign which you want to convert, for which you have to write the value. If it is positive, add the sign bit as 0. If it is negative, add the sign bit as 1. Done. So you can just write here plus 35 value is 0 1 3 times 0 11, and minus 35 value is 1 1 3 times 0 1 1. Then don't consider as 35 value this is. The 35 value is only this much, and the first is always your sign bit. Done. So this was the first example I had taken. Let me take few more examples so you will be perfect in this representation. Done. So next I'll go for 45 plus or minus 45. We'll see. We'll try to convert plus or minus 45. Done. So the very first thing what you have to do is you have to convert 45 to binary number. Done. We are referring the method sign and magnitude. Sign and magnitude representation. Done. So first I have to convert 45 into binary. So 45 divide by 2. 2 2s are 2 2s are 1 is a remainder. 2 1s are 2 1s are 0 is a remainder. 2 5s are 10, 1 is a remainder. 2 2s are 4, 1 is a remainder. 2 1s are 2, 0 is a remainder. And 2 zeros are 1 is a remainder. So first remainder is your LSB. The last remainder is your MSB. Answer should be written from MSB to LSB. So 45 is equals to 101101. So 45 is 101101. Done. Now we have to write the value for plus 45. So what I have to do is plus, the sign bit is plus, means I have to add 0. Value of 45 is this one, 101101. Done. So this is your magnitude. This is sign bit 0 because the number is positive. Done. Now we'll represent minus 45. So minus means we know that sign bit should be 1 and the value of your 45 is 101101. So this part is your magnitude and this part is your sign bit. It is 1 because the number is negative. It is 1 because the number is negative. Clear? How to convert a given number in the format of sign and magnitude representation. Then let me take one more example. If we have any confusions, you have to clarify. Then so I'll take now a little bit bigger one. We'll go for 84 plus or minus 84. Done. So 84 divided by 2. 2 4s are 2 2s are 0 is a remainder. 2 2s are 2 1s are 0 is a remainder. 2 1s are 0, 1 is a remainder. 2 5s are 0 is a remainder. 2 2s are 1 is a remainder. 2 1s are 0 is a remainder. 2 zeros are 1 is a remainder. Now your first remainder is your LSB. The last remainder is your MSB. The answer should be written from MSB to LSB. The answer should be written from MSB to LSB. Done? Now, we'll write the equivalent value of 84. 84 equivalent value is 10, 10, 100. So, I'll write 10, 10, 100. Now, we have to represent plus 84 and minus 84. So, plus 84 is first sign bit always. Done? So, plus means it is 0. Value of 84 is this one, 101013, 2 times 0. Done? So, this is your sign bit. This is your magnitude. This is 0 because number is positive. Similarly, minus 84, the bit sign for minus is 1. So, the value of 84 is 101012 2 times 0. This is your sign bit. This is your magnitude. This is 1 because the number is negative. 1 because the number is negative. Clear? Like this, you have to represent a number with its sign using your sign and magnitude representation. Sign and magnitude representation. Done? So today I am covering only one method. I will not make you confusion so that you should get comparative between the other representation. So clarify only the first method, that is sign and magnitude representation. It is an easier method. Then what you have to do is just take the given number, convert it into binary. Then you have to just see. Positive means add 0 and negative means add 1. If you write that much is over. Done? So take the homework. The first one, get the value of plus or minus 57. Second, plus or minus 98. Third, plus or minus 119. Fourth, plus or minus 179. Fifth, plus or minus 128. Done? Solve these and send me the answers. These all should be displayed through your sign and magnitude representation. If you have any doubts relating to this representation, ask me, I'll clarify your doubts. And other method of your signed representation, 1s and 2s complementation, that we'll see in the next class. Thank you.